Have you seen the method?
Yeah.
Okay. 1 minute past. Welcome.
Okay, so welcome everyone. So for the next half an hour, we'll have Chris Little from the Met Office giving us a talk on OGC API, environmental data retrieval, progress and plans. So OGC API EDR progress and plans. So without further delay, over to you, Chris.
Okay. This is kind of I'm Chris Little. I've been a meteorologist for a long time. I've had several interesting careers, and my current career is the last dozen years or so getting involved with the geospatial community and trying to convince the geospatial community that the world is not a 2D flat map that doesn't change, but it actually is 4D and it's changing all the time. And we're having some success with that, aren't we? Right. So that's why me. But why have we got an EDR, Environmental Data Retrieval API? And the simple answer, big data. As soon as you go to multi-dimensional data, the data gets bigger. You add the vertical, you another order of magnitude of data. Add time, another order of magnitude of data. Put probability in there, like ensembles, another order of magnitude of data. Big data. The big data is dumped on your front lawn in a great big crate. You can't move it, right? You can't do anything about it. You may prise the lid off to find out what's in it. If you're lucky, there is some metadata on the outside as opposed to being inside the file, right? So imagine this is where we've been with containers such as NetCDF and GRIB and HDF. They're all kind of container formats, and the metadata is inside, which is not very helpful. Right? And actually, what we want the data to be like is like this. You want all the data nicely divided up, and it's transparent, and you can see it, and you get just the bit you want. Okay. Now, so the traditional map layers are broken. So as soon as you've added 3 or 4 dimensions, instead of having 10 sets, 10 levels of data for 10 different times, that's 100 levels. You could pick those off a menu for web map services. But once you've got 100 levels, 100 times for the data, 100 parameters, and you've got some ensembles, different variations of a given piece of data, you've got 100 million layers. That will not work on a menu. So your client has to be intelligent to be able to find that data. Right? And you can't move the data. You're constrained by the speed of light. You just can't move data that fast. Anybody in the room know how far light travels in 1 nanosecond? In 1 nanosecond, light travels 30 centimeters, 1 foot. If your computer is bigger than that, you're going to have problems, right? Right. Now, and the traditional approach is coverages, right? Peter Bowden, Fred Peter's not here. People just say, oh, you can trim it or you can slice it, right? But actually, if you've got a petabyte of data and you take 1 slice out of it, you reduce an order of magnitude. So instead of having a petabyte of data, you have now only got 100 terabytes of data, right? Still, you can't move the data, right? Even if you resize it and resample it, that's an expensive process. Again, you can't do it. So how can we reduce the data even more? And that's what EDR does. So here's a great big chunk of data. Give me the data at 1 point. Give me the data at 2 points. Give me the data above and below the point, because we've made Z and time, vertical and time, our first class. Got 4 coordinates, not just 2. And you could have a time series at a point, right? So, give me the data at a point, give me the data before and after that point, right? So you've got a time series. Right? So that's 1 pattern. Another pattern is at a point, give me all the data. This is kind of a polygon, really, with infinite number of sides. Give me all the data within a radius of a point. That's a very convenient way of doing things. And again, above and below or before and after. So you've got the 4 dimensions. And you can have a polygon. Give me all the data within that polygon or above and below the polygon. So a prism or before and after. Same thing with prism in time. Ignore the right-hand thing. A cube is just a shorthand way of doing a polygon. It's convenient. Lots of the polygons are rectangles. So we've had a shortcut convenience abbreviation for the query. And we have trajectories, which is something new that you don't generally see. The trajectory can be 2, 3, or 4 dimensional. airplanes fly 4-dimensional trajectories, right? They go X and Y, they go up and down, and they take 9 hours to get across the Atlantic and the Pacific or whatever, right? So, yeah, so you've got to have all 4 dimensions. But you could have a 2-dimensional one on the ground, and whatever's traveling along that trajectory does it in infinitely fast, right? So, yeah, so it's a route trajectory. So they're all in there. And the other thing that's really useful is fat trajectories. So you've got a trajectory, everything within a certain radius of that. And that's exactly how airplanes fly across the Atlantic. They're not told to follow that route, you go down a corridor. So those are all the basic queries we've kind of thought about, right? And that's all in one slide. It's all kind of, the query is part of the URL. You have your collection of data, a specific collection all fits in with the APIs, you know, the common landing page and the common part 2, geodata collection, and then you have those query types, positions, areas, radius, cube, trajectory, corridor. And we've added in a couple of other collections because we're following close on the coattails of Clements, and we started using features clients to see if this works at the original hackathons. And so we've got location and item completely compatible with features, but not all the features. So that's where we are. And the syntax we're using is well-known text for the coordinates, ISO 8601 for the time specification, and that's it. Right? So the syntax is pinned down, and we support any number of formats. Right? It's data model neutral. To use Johan's terminology, it's data model agnostic. It's the issue for the collection owner, for the service provider, to go through the sweat of answering the queries. It's their fault, right? You're making nice and simple for the users, and it's scalable. So that's the overall summary, and what we're going to do. Right. So we started in 2018. Lots of people were already using APIs. We got involved in the original hackathons, and then we got the first standard published in 2020, compatible with features and compatible with common part 1 and part 2. The common part 2 hasn't been published yet. Sorry, that wasn't to dig at you. Right, okay. So a year later, we did a corrigendum. And you think, oh, made a mistake. We made some mistakes. We loved this idea because it proved people were reading the spec. And that's great, because one of the worst things in OGC is you go to public comment. I've got my big document. Any comments? Nobody. Has anybody read it? No. Corrigendum proved people were reading it, and it also proved they're reading schema. Right? So we found some schema mistakes. Right? So that proves people thinking about implementing it. That's great. That's 2022. So then in 2023, we went to version 1.1. We added some convenient things. So in particular, we allowed post as well as get as an HTTP method. So if you're doing a polygon and the polygon happens to be the coastline of Norway, for those who know about slightly fast, he would really appreciate that. But the polygon is very big and very complicated, and you run out the limits of your HTTP URL. So by doing post, you can do in a form, blah, blah, blah. So that's easy. But the most important thing is we allow extra dimensions, not just X, Y, Z, and T. You can have categorical dimensions. You can have a dimension of bird species seen in London, organized by Spanish the alphabetical order of the Spanish name, or the Latin name, or the ornithological order, or whatever. It doesn't matter, right? That's categorical. Or it could be wavelength, so another coordinate, any of those kind of things, right? So we've added those extra dimensions, and it makes the queries much easier than being kind of stuck with a kind of slightly rigid web coverage kind of approach where it's X, Y, Z, and T and everything is range. And we fixed a few problems, like we were going to have corrigendum for 1.0.2, but and we folded those into 1.1. So again, it proved people were reading the spec and they were trying to implement it. And and they're reading the schemas and so on. The schema and the text are different, which is right. The schema, right? And we just made some things a little bit more convenient. And that thing about aggregation metadata, the CFNet CDF people said, well, I've got a value here. It could be a pixel value or whatever. So what actually is it? And they say, oh, well, it's the average of the whole square or the maximum or the minimum, or it's some other complicated variation to represent the data at that point, right? So we've added that as a control vocabulary. So you've got some mechanism for giving extra metadata about the value you've retrieved, right? So where are we? Well, we've got 1.2 is approved. It's approved at the end of last year. We're waiting to be published, but it can't be published till Common Part 2 is published. So actually, I've pestered Gobe. If you just publish Common Part 2 schema first, even before you do the editorial document stuff, that would make our life easy, because we're referring to Common Part 1 and Part 2. So why should we have, they're all meant to be a family, right? And having a reference to a GitHub location for a schema is not a good idea. Definitely not a good idea. Right? And we've had a few more convenient things. And we've made the transition to support OpenAPI 3.1, which means you could use JSON schema as opposed to YAML. Okay, so we're just moving with the times, and we had some little minor improvements, like if you want to request multiple locations, you can, rather than just doing one at a time. And some documentation errors. The text is wrong, the schema is right. So that's where we are with 1.2. Along the way, we thought what was going to be 1.2 turned into Part 2, publish and subscribe, event-driven events. And we kind of floated that in Frascati, and it worked really well. We actually implemented it and demonstrated it on 3 laptops in the coffee bar in Frascati until the coffee bar owner threw us out for not buying more coffee. And it worked really well. So you could use any protocol. We're using async API to specify the information flows. And you can do it with Atom or all sorts of different things, and it works. And that's Part 2, and has been implemented quite a lot of places. And it then turned into a generic sub-swig, which Tom Creedis, Clements, and Peter Vetranos are the co-chairs, and they meet not quite monthly, less than monthly, but basically they're going to make a generic pub-sub API for all the other APIs. And the main difference between the EDR version and the generic one is we made an assumption that the information structures reflect the data structure. So I want that kind of data, so I've got some information telling me about that kind of data, but you may want something that's completely different. So that's where we are. That's all kind of done, right? And now we're working on Part 3. It is just about to be reviewed by the OAB next week, I hope. Greg still hasn't issued when the meeting's going to be. Anyway, I think it's next week. And this is lots of implementations. And people are discovering that they're interoperable, but they're not, because they're flexible. What did you call pressure? I called it pressure. No. I called it Druck. I call what's Spanish for pressure?
Pressure.
Pressure. Okay, so that's not a problem, but it's German, it's Druck, right?
German.
So, well, let's all agree to use English, right? Okay, that's a profile. It's a restriction on the standard. So, and we've got this pressure coming from the defence people, from international aviation, and from all the Met services in Europe and around the world, right? And so there's been lots of initiatives and some links there. Rodeo is a big European thing where they're going to implement the EDR API in 28 European countries. And let's all agree we're going to use them. These are going to be the names we're going to use, the CRSs we're going to use. These are the payloads we're going to use, because we didn't specify any payload. We recommended code JSON, but no, you can use NetCDF or protobuf or whatever you want. And so, and there's a working group, sort of overlapping OGC, working on profiles of how would you retrieve observations, climate data, radar imagery, warnings like gale warnings or tsunami warnings, and weather forecasts, and some of the core stuff in the middle as well. And so that's all work in progress. So in the next couple of weeks we should be able to go to public review and turn the standard when we can. Now, the interesting thing about this is other APIs probably have service profiles, should have service profiles. API maps. I'm looking at you, John. We can definitely see, okay, we've got a domain of users. We've all agreed we're only going to use, I don't know, Web Mercator, or we're only going to use Polyster Graphic or whatever, right? And we're only going to use this symbology, right? Enemy tank's going to be red and the ally tank's going to be green, right? You agree those conventions? It's a profile. Are you going to specify it in Map API? So there's a potential that you could have a service profile mechanism, API approach, that goes across a lot of the APIs. Right? So that's up for grabs. And this is Chuck Hazel's diagram of, say, so in the bottom right, you have a profile of a standard. So it customizes the implementation, but it conforms to the standard. So this gets around the ISO definition of a profile extends or restricts. Well, original thinking is restrict, but actually, if you've got something like, say, well, it's only optional to use the trajectory query, and if you're then mandated, is that an extension or a restriction? Don't know. So we just sidestep it and just say a profile has to conform to the standard, and it has to. So that's where we are, part 3. Right. Other things going on. Well, the main other thing is on coverages, right? Some stuff on coverage JSON, because we tried to standardize coverage JSON first, and we ran into those barriers, and we tried to get standardized in W3C, and W3C, no, this is data formats, that's not our thing, right? So we could bounce back, and then Scott suggested we do a community standard, and that's where it is. 1.0 is a community standard. We're working on 1.0.1, not so much as a correction as there are some things from the standard pointed to community websites, like the schemas are on the community website, and the prefixes and the JSON-LD context files are on the community website, and we're now going to put them in. We have put them in the naming authority registers, so now it's more all bound up in an OGC bundle. So that's what version 1.0.1 is doing, and it's still a work in progress. And we've agreed later this year we'll start working on how to add extra dimensions, such as a second time dimension or ensemble dimension, and consensus developing, but without John Blow, that the extra dimension will be called X, Y, Z, T, and E. Somebody suggested M from well-known text, but no, it's not quite happy about it. Anyway, so that's and what's interesting is in version 1.0.1, we put in the links to the JSON-LD context files, and we also put in the observations and measurements and sampling namespaces, ISO 19156. So therefore, we can put in loads of observation metadata, and if you don't know what it is, you just skip it, but it's all in there. Don't have to reinvent it. And the time series markup language working group are doing version 2. Really happy with that. Yeah, so we're starting to get this overlap between what all the observation people have done for years and never talked to anybody doing on the courage side. Great. Plans. 1.3. This to start this later this year. We haven't actually put anything up on the. We haven't put any tags or anything yet. About to 1.3. We think we're going to split up the conformance classes. Okay. When we did the original standard 1.0, we didn't know what conformance classes were. We said, "Oh, let's have a minimum number and make it as simple as possible." Right? That was a mistake. So what we're now going to have is: do I do areas? Yes, conformance class. Do I do trajectories? Yes or no, conformance class. So we're going to have much finer granularity, and that fits in with a big push to building blocks. So that's the refactoring, but nothing else. But actually, we've changed minds, and what was going to be, there's a few other things like multilingual support for metadata and things like that. But actually, we were going to do a part 4, aggregations and statistics. Now, this is not what Jerome wants to do and what Clemens has done with features, i.e. a full CQL2 functionality. We think that is not sustainable and not scalable to the level we want to scale it for terms of thousands of users, because it's an open-ended query language. It's a Turing complete query language. It's a denial of service attack in sheep's clothing, right? So we're going to say, okay, you can request the maximum value, the minimum value, or the average. Very simple things. So you just pre-calculate them or do them on the fly, but it's not too expensive. And of course, what I should say, the statistics are not for the underlying field or data, it's for the bit you retrieve. Give me the temperature all the way along this trajectory. Give me the turbulence, or give me the wind speed. And by the way, what's the average, or what's the maximum, what's the minimum? And just for that query pattern, I think it's really useful. So we're planning to do that, and we'll start work on it. And we're probably going to put it into 1.3. So we'll do two changes. So we'll do the granular conforms classes, make a building block, and we'll add the functionality of aggregation statistics. Save the hassle to approval process. So we'll actually add functionality that the users will see. And just saying, oh, you've got to go to 1.3. What benefit is it? Oh, you've got finer granularity of the conforms classes. Yeah, but what benefit is it to me? Anyway, so okay. And there are some risks with part 1.3. Do we deviate from part 2? Do we deviate from part 3 of the common? I think so likely. I've looked at part 3. Doesn't make any difference to us really. Part 2 pub sub, the generic pub sub, maybe that will change, but so far it hasn't. No, that Clements and Peter Vitranos and Tom Cornelius are keeping in line, so that looks okay. Whether the service profiles from part 3 for EDR look anything like the other APIs profiles, don't know. And there's at least 3 mechanisms for profiles. You've got HTTP profiling. You've got profiling redoing it at a kind of query level, but there's other things, other ways of doing profiling. Right? So I think it's a new area, so we don't know really. And aggregation statistics, I know we're going to diverge from CQL2 part, whatever it is, it features, and what Jerome wants to do with the coverage API. But we're just doing that to restrict it and keep it nice and simple. Do something simple first. Let's walk forward. That's where we are. Discussion. Implementations, lots of them. Okay. So first time round, we had the UK Met Office, National Weather Service, IBL, a commercial company in Slovakia. They were one of the first implementations, and they were certified and a reference implementation. Met Service of Canada did a Python implementation. That's Tom's work. Again, certified. All the Scandinavians produced their own implementations. The Dutch had a really interesting one as well. The Dutch did something really interesting, which I'd never thought of, was they have a public web map service. So you can go into the Dutch Met Service website and call up some weather map. And the web map service is being fed by EDR. Like, ooh, cool. And I said, Rodeo is this project for 28 European countries. NetCDF, I'm not quite sure what NetCDF are doing, but they are planning some if getting funding. Wuhan, my co-chair in Wuhan, did a demo for typhoons going over bits of China and things. Hainan. That was interesting. And so WMO has already planned and started deploying EDR across 193 countries. The DigiWig people have got it into their profiles, into their standard lists, and International Aviation doing the same thing. That's it. 5 minutes for questions. Anyone in the outfield? Anyone there? Are they all coming?
No, they're here.
Okay, fine.
I have a question.
Okay.
So, are you aware if any other standards done this service profile?
No. We did a little experiment a couple of months ago. We tried to do a workflow profile of EDR retrieval, processing, API processes, and API maps. Process, you just say, oh, get me these data, subtract them, and then pass it to the map. So we do a difference map, which you have got. Yeah. So that is kind of a nice idea, right? And sort of works, apart from when we got to maps, we said, oh, okay, you want that parameter at that level, and that parameter at that level, and you take the difference, and that gives you the thickness of the atmosphere, which is the same as temperature. Jerome says, if you get two different parameters, it's two different styles. Personally, I don't think that's right. If you've got a parameter, just a different coordinate, why would you want to change the style? I'd say the style is plot it in green, put the numbers, or plot the wind arrow in red. And it doesn't matter whether you the wind arrow at 500 millibars or 1,000 millibars or 300 hectopascals, right? You still want the wind arrow in red. So I would say that's a kind of consistent style. But Jerome says it's a different parameter at a different value, therefore you must have a different style. I think so. There's a mismatch in the concept of a style. So that's we haven't got past that yet. So I think the potential is there to get quite a lot of synergy, but we've got to get some fundamental ideas right.
Do you think this is something that could be in common?
Yes.
Okay. So you thought about it.
Yeah. Common part 4, part 5. How far's common got? Oh, they just up to part 3, right? Just up to part 3, I think. Maybe I should have a target that EDR doesn't have more than 3 parts, right?
EDR is generating all these extra standards.
Right. We know
like
what we're doing.
Pops up became its own standard and all.
Yeah, that's right. But then we're implementation driven, right? This is we're going back to these people have implemented it and saying, look, this is what's going wrong, right? What this works, what doesn't work. So the other thing we're working on is a profile generator. So actually, it's a bit complicated getting this profile to work, because basically, how do you get a test of profile? Well, it's got to be testable, right? So therefore, there's got to be kind of a schema, and you can do a JSON schema, and that's what we're planning to do. But get somebody to write a JSON schema. Oh well, let's automate it, and we use Pydantic. That's what we're currently doing. So we've got a repo where we're developing that tool. But then come along, Alessandro says, "Oh well, we'll all do this with Rainbow building blocks." We're just going to do what we want to do, what we can control, and then say, "Well, okay, how does it fit in the building blocks?" Right? So we're all going in the right direction. But it's a question: how do you do it? You can all sit in a room and argue, like electing the Pope. Smoke comes out. Now go and implement it. No, we'll implement it first.
Are these all server implementations? This list or
both
server and client?
The client's pretty easy. You can just use Leaflet.
There's also a QGIS client.
Oh, we've got plugins for QGIS.
Yeah, plugin. Yeah.
They're there.
It's not on the list, is it?
Oh yeah, okay.
No, I don't know. I'm asking.
It's
a question. I don't know. But it's quite a nice.
So one additional detail about that final bullet point there is that I think the WMO network is it 60 or 70 instances nodes on there using the
WMO infrastructure number 2.
Yeah, which has PyG API underneath it.
Yeah.
So it's quite it's
quite a large scale deployment of.
Oh yes, so when WMO does a pilot, we don't just say, "Oh, it's been implemented in the UK and it's been implemented in France and in Canada," right? It's been implemented in Zambia, Vanuatu, right? Laos. I don't know. I know it's done in Zambia, definitely. But I think maybe Ecuador, something like that. Basically, there's 5 or 6 regions and just do one in each, right?
Yeah, I think Tom did a workshop in Namibia as well.
Yeah. Okay.
Around the WIS2 framework. So it's a huge community and it's a growing community as well. Because I recall I was reading some report from some event the other day, and I didn't expect to see EDR mentioned there, but it was, and it was from an organization that is not involved in the OGC. So it's I think it's there's more to come in terms of more implementations, etc.
The only thing I can add really is EDR is slightly misleading name. It says environmental data retrieval.
Yeah.
We had big arguments what we should call it, and the original argument was it spatiotemporal. Any data that's got consistent spatiotemporal coordinates is applicable. So the use cases I mentioned were picking things off from microscope slide. Give me the count of all the red blood cells within this slide, or something like that.
Yeah.
Or give me, I've got a 3D scan of a human body. Give me the average density along the trajectory of their left femur.
It's continuous data, isn't it?
Yeah.
Continuous data.
Yeah.
Space and time.
But we didn't like STD in English. So.
Right.
Oh, okay. Yeah. Makes sense.
Any more questions?
One question.
Yes.
In terms of time series data that you have mentioned,
Yeah.
I just wanted to check your perspective about some component-based 3D model that we have. For example, if you want to connect these time series data to our beam model, for example, is there any recommendation that you have for us? Because we want to create a digital twin, which is can show the real performance of renewable energy projects.
Yep.
And then I want to, for example, we have some IoT data sensors, and those data should have some channel to these 3D components.
Yeah.
So
what do you mean by digital twin first?
digital twin is a 3D model of a project. Which
Okay, let me give you my definition, right?
Yes.
Digital twin. There's a hierarchy of digital twins.
Yes.
So at one level, you're just trying to capture the features of something, and you capture those features as the reality changes. You update your model.
Yeah.
But it doesn't have any predictive value. But you may then go to the next stage where your model is accurate enough that you can say, well, actually, if I tweak those knobs there, suggest that it might go that way. And then reality may or may not go that way, right? So you've got this predictive effect.
Yes.
And you've got the processes modeled rather than just kind of the outside shape of it as well.
Yes, exactly. You're in the same page.
Yeah, okay.
Yes,
Yeah, okay.
So
You've just got to have the feed and you've just got to have the verification. You've got to have this feedback loop. And so how often do you do a feedback loop to update your digital twin? How do you verify your meteorology's done this for years, right? Because we do a forecast and we verify. We wait till the 3 days have gone and then say, well, what whether actually happened, what did we forecast? And we keep all those statistics and that feeds back in the model.
yes. So do you have any idea about these kind of APIs that you have mentioned? Can we use some of those for implementing this?
Don't know.
Well, I if I understand, I'm going to make some assumptions about the type of data you're working with.
Yeah.
I'm going to guess that it's to do with discrete objects like buildings or cars or
Renewable energy projects like green turbine.
right, yes, exactly. So individual entities. So we do have a couple of standards that are designed to enable you to get data from sensors that might be attached to an entity of some kind, like a building, and then from there to get data from those and into a network and through to a client application or through to another service, etc. So we've got one particular standard, OGC API, connected systems. And then there's another one called OGC Sensor Things API. Those are the modern ones, and then there's some previous generation ones like Sensor Observation Service. In fact, Sensor Observation Service is deployed by DEFRA, the UK's Department for Environment, Food and Rural Affairs, I think, or something like that.
But don't take that as a recommendation, because when I talked to the scientists involved in DEFRA, I said, we wish we hadn't done that.
Well, they had to do it because Inspire said they had to do it, so they had to do it.
just because Inspire says you have to, doesn't mean you have to, right? We didn't.
Yeah. So, but yeah, the modern ones are OGC API connected systems, and there'll be a series of lightning talks tomorrow about that. And OGC Sensor Things API Andreas Matthews and in fact and Joan so they've deployed those instances. I think Joan's is used for biodiversity monitoring, I think. And I can't remember what application Andreas is using it for. But with that particular standard, you can transmit measurements, and not just the measurements, but even like the units of those measurements. So I don't know, 28 degrees Celsius, that type of stuff, or what's the or anything, pressure, air pressure, etc. But you can also, but they're also self-describing. They describe the features that are being observed. So, for instance, you can say I'm monitoring I'm monitoring the air at this particular building on this particular street, and then from there and then every measurement that you take related to that building is then linked to that particular building. It just makes the whole process more efficient because you don't have to duplicate a lot of the information then.
I think the other thing that's worth mentioning, I haven't mentioned it, is some of our other activities is API records, which is the catalogue and connection with Stack. So in the UK Met Office, for example, at the top level, at the remote global level, it's a records API. You can access it, and then but actually we've stacked a lot of Stack. Because Stack's really nice because it has no moving parts. Right? Yeah. You just expose your assets, and all of the search engines and the bots just come across the web and just search it, and bang, everybody can find it. Right? So we've got a hierarchy of stacks. So we may have a category of data, and that's one stack set of records, or records. And then beneath it, you then can refine it. Yeah, so that sort of fits in with that kind of approach that Gobi's mentioned. So you may have all the observations for a building, but then at some point you want to have all the buildings. Yeah? So rather than stick them all into one big monolithic catalog of some kind or database access mechanism, you could have this hierarchy, and then you could get automatic, and things kind of automatically trickle up and down as things get changed.
Yes. Yeah. Exactly. Thank you so much for your recommendation. One idea can be used here as some data from Met Office, for example, could be the prediction of the future weather to understand the performance of a renewable energy project, and then we can analyze and compare if that, for example, a particular renewable energy project is have a good, for example, performance based on those future data or not. So
and those data are being made available. Okay, some of them are not available as collections that are readable by the APIs, but quite a lot of them are now. It's infrastructure change, and it's taking time. But it's completely built into our infrastructure plans.
I think, and one key thing is the use case you're describing there, EDR is actually ideal for it because what you're describing there, like change of weather, you're effectively describing a coverage. So when I picture it, I'm picturing a phenomenon that changes space and time. So effectively, what you would be doing is, even if you are taking multiple measurements at various locations, when you portray or visualize it or use it for analysis, you most likely interpolate what the weather is between all of those data points. So I think EDR is probably one that you would want to use there. And then the other thing I'll just add there is the pub/sub angle. So with pub/sub or publish/subscribe, effectively they were looking at event-driven architecture, whereby if some of the measurements, well, you could set a rule, right, that if the weather exceeds a particular threshold, then a notification should be sent to subscribers to say, a major event or whatever has been has been triggered, so respond accordingly. So the part 2 of EDR is designed to support such event-driven capabilities.
But then when you set your thresholds, you should really think about it, because been through this many, many years ago, setting up the European Meteor Alarm Warning System, where you go in and look at the weather warnings for all the European countries in any language you want. Though actually, when you drill down, you get the language it's written in. But at the top level, the maps are all in whatever language you want. And we used to think, well, okay, snow, we're going to have snow, right? We'll set a threshold of 2.5 centimeters for London and Paris, because at that point, 1 inch of snow, the city's ground to a halt.
Yeah.
The Finns won't get out of bed for less than 2 meters, 6 feet of snow, right? So having absolute thresholds is something to be wary of. Actually, what you're really interested in is the impact.
Yeah.
So if you can relate the threshold to an impact, and then you set the thresholds and the impact. So, for example, really heavy rain, the river's gone up by 1 inch, don't care. Oh, well, actually, this is the flood level. It's half an inch below. It's gone up by 1 inch, disaster. So you've got the same absolute threshold of what you measure, but the impact is completely different.
Yeah. There's a question online. Andrew, you have your hand up?
Yeah, I work on behalf of DEFRA implementing the SOSA SSN standards for ecology data, Chris. So lovely to talk to you and meet you.
Okay,
and I understand.
Fortunately, I've forgotten the names of the people who told me that they hadn't done it.
Yeah. Yeah, don't worry, I don't need names. But one of the issues that we have with respects to reflecting ecological data to existing standards that, let's say, OGC typically use, like EDR, is that our data is substantially sparse. So we can't have a continuous variable between, let's say, 2 fish sampling points, because the land that's in the way, you can't have 4 bass there. It's just not going to happen when it comes to our our work.
Yeah, that's why we set up the categorical dimension.
Yeah.
So it's an enumerated list, basically. But then you also have the same thing with a hydrologist, Dave Blodgett in the USGS. That's why he's got the features and the items, which are kind of the feature discrete approach as well. So.
Yeah, but we're looking at specifically the problems that we have to deal with subsequent samples and samples of samples, and then the actuations that are supported largely by SOSA SSN. But one thing that would be quite useful is to demonstrate how the 2 profiles can combine to help resolve questions like land use relating to farming, leaching into waterways of phosphorus based off of rainfall. And that's work actually that we're currently undergoing. And it's quite useful for me to understand the EDR approach to capturing this information, which is going to help us derive better analysis of, let's say, nutrient neutrality expectations of protected waterways within the UK.
Yeah. So I think the interesting thing there is that you've got a kind of a relatively well-defined workflow, and it's then how do you kind of make it really interoperable or sustainable over time? Yeah, and
absolutely.
Whether you can kind of unplug a bit in the middle and plug another bit instead and still get comparable results.
Indeed.
Yeah.
Thank you. It was a very interesting talk, though.
Thank you. Any other questions or comments for Chris? From the room or from
I've just got a comment about records and Stack.
Okay.
You know that Stack has an extension library of Stack extensions. And somebody from the space community, I think it's from ESA, has just done a liability extension. So increasing the metadata for quality and liability. So when somebody uses your satellite image and does the wrong thing, and a lot of people get injured, and a lot of people get killed, and a lot of people get sued, you've got the information of the provenance and liability. And we're thinking, actually, maybe there will be a part 4 of EDR. That is, how would we do this standard exposure of provenance, which is what you need for liability. We may skip the liability bit, right? But certainly getting provenance. And what they have done is they have actually used the W3C Provo ontology. So it's the first time I've seen a Provo ontology actually used for real as opposed to an academic argument.
I think DDML was also using it.
Are they? Okay.
So, I mean, that sounds like a really good case study. In testbed 21, we did some work with OGC API processes and stack and records, also within the context of IPT or integrity, provenance, and trust. So I think maybe
that would really fit in with IPT.
Yeah, so maybe for the next testbed, you know, funding permitting, or you know, if there's any sponsors are you know around, you know, maybe with that one we can look at an EDR based use case and see how that could be fit in. I did watch the news the other day. It was basically just satire, and they said one of the complaints people always give when it comes to weather forecasts is, you know, what you said the weather would be like on at a wedding.
Yes.
So I'm planning my wedding. It's in a year's time, and then I ask what's the weather going to be like. I mean, a year is a long time, right? There's no way you can get a.
Well, the standard meteorological response is if the weather's fine, take your umbrella. If it's not, it's your choice.
Exactly. So yeah, so it will be interesting how to see how the liability claim thing comes in that situation. But anyway, I think it's been a great presentation, a great discussion. So let's thank Chris for an excellent one. Okay, thanks everyone. So I think there's a lightning talk later on.
15 minutes.
Is that in 15 minutes? Oh, okay, yeah, in 15 minutes. It's on artificial intelligence for discrete global grid systems, DGGS.
And I think it's the last one today.
Is it the last one today?
Yeah.
Oh, okay. Okay.
If it made DGS simple, you wouldn't need AI, would you? Right? Sorry.
Okay.
So